Alright everyone, let's go ahead with our second tutorial on LabVIEW. Today we're going to look into case structures. So right away you can see I've set up my front panel and block diagram side by side, which is what I like to do. So I have my controls palette on right here for the front panel, and then I have my functions palette for the block diagram right here. So I can easily access both of these palettes for each of these front panel and block diagram. So let's go ahead and look into case structures. So we would want to, obviously you would find these structures in the block diagram because the structures are logical in nature, they are algorithmic in nature, so you wouldn't find them on the front panel, you would find them in the block diagram, right? So you go ahead with the functions palette, look into the structures, and there you have a case structure. So you would draw a case structure such as this right here. So you would see two things when you draw a case structure. You would see this case selector, this green little question mark, which basically requires an input. So this case selector, as the name suggests, requires an input that would allow it to select which case do you want to execute. And the options of cases that we have for this instance are true and false. So you need to supply an input, which obviously would be Boolean input, which was going to decide whether to run the true case or whether to run the false case. Okay, so those two cases, you need to decide which case do you want to run. So that's about that as far as setting up the case structure is concerned. So let's in fact go ahead and provide an input to this case selector and implement a very simple example as well. So I would need a Boolean input. I'm going to go ahead and choose a vertical switch. When I choose a vertical switch, I would want to place it outside. Maybe I can just set it up here and connect this. Okay, and connect this with the case selector. Okay, so this way this switch is going to decide whether to execute the false case or the true case. Okay, so next up what I want to do is set up some some constants maybe and display those constants. So here I am in numeric and I am looking for a numeric constant. By the way, if you don't see the icons and the numbers with your with these icons, you can always go into customize, view this palette as, and choose category icons and text. So that way you will see these this text beneath every icon as well. Okay, so if I just had a standard icons, that would just be icons, and you might not want to choose that. You might want to see some description as well. So the best way to go ahead with it is to choose icons and text, both of them. Okay, so I'm going to go ahead and place a numeric constant in the true case, and I'm going to give it a value of 20. Okay, yeah, 20. Okay, so I'm going to give it a value of 20 in the true case. In the false case, notice there's nothing in here, so I'm going to go ahead and choose another constant, give it a value of 30. Okay, so remember, in my true case it's 20, in my false case it's 30. Now if I could just display this as an indicator, and then I would use this switch to change my true or false case, and that indicator should display the corresponding constant value. Okay, so what should I be looking at? I should be looking at an indicator, which is right here. Okay, so let's just place this indicator here. Now you might be tempted to connect this wire directly to this indicator, which is okay, but remember it's just attaches to the wall of the switch of the case structure, and then from there on you could just make a connection like that. Okay, so that's a fairly simple way to get going. But so this is for the false case, as we can see. Well, let's look at the true logic. Yeah, so for the true case it's not connected, which is why you wouldn't be able to run it, and in fact you would be able to see the error that would be generated as a result. There you have it. So the error tells you each time there's an error, you just go ahead and click it, list errors, and then you would be able to see the errors. The detail for the errors here, you are always encouraged to read through this detail. In this instance, it tells me that the case or event structure does not have anything wired to the output tunnel, right? So we wired it for the false case, but we didn't wire it for the true case. Okay, so that's the kind of error that we're dealing with at this point in time. Yeah, so I'm going to wire it. So again, so you see, for the true case it's 20, for the false case it's 30. You need to make the wirings and then go ahead and run it continuously. Okay, so once this is up and running, remember the logic that we designed. We wanted this switch to control which case to execute, whether true or false, and whichever case it is, it has a specific number for that case, which is going to get displayed here. Okay, so if it's true, it's 20, if it's false, it's 30. Right now the switch is down, which is false, and it's displaying 30. But when you turn it upwards, which is the on state, the true state, it shows us 20. Okay, so there you have it. It displays the number according to the case that it is executing. So that's the first example that we wanted to go ahead with it. Okay, so for our second example, we are going to go ahead and implement a case structure, but this time instead of Boolean inputs, we are going to instead of Boolean cases, the true and false case, we're going to choose see if we can have more than 2 cases. Okay, and for each case we are going to see if we can implement something different. Okay, so I'm going to choose a numeric control right here. This control is going to, and I'm going to feed this control to the case selector. Okay, so exactly when I do this, you can see how suddenly it shows 0, 1, and by the way, if I right click it, I would be able to add a case after 1, which is 2. I can add a case before 2, or I can add a case after 2, right? So I can have multiple cases. As you can see here, I have about 4 cases. 0 case is the default. I can change that. Okay, so for example, I could choose, so if I could get rid with the default here, and I could choose case 2 to be the default case here. Okay, so I could do this. So why is choosing the default case important? I will tell you why. See, because we have a numeric control as an input, that means we can choose any of these cases, 0, 1, 2, 3, 4. But what if a user enters 4 here or 5 here, which would correspond to a case that we have not designed? So any number, any case that a user enters by mistake, or even just for checking purposes, for debugging purposes, any case that a user enters here which is not defined, that would mean it would run the default case. Okay, so that is why it's important to always have a default associated with any one of these cases. Okay, we have associated it with 2. Naturally it comes with 0, but you can always change it by just writing it down as I did. Okay, so let's go ahead and populate our cases. Let's write some things in these cases. Let's implement some things in these cases. So what I'm going to do now is I am going to, in fact, allow a user to have 2 numbers. Okay, I'm going to let the user set up 2 inputs right here, numeric 2 and numeric 3, and I'm going to let the user perform different logical operations in these. For example, I am going to let the user add in case 0. I'm going to let the user multiply the 2 numbers in case 1. I'm going to let the user divide in case subtract in case 2, and in case 3 I am going to have them let's have the user do something like a square in case 3. Okay, so let's go ahead and implement this. But whatever the user is going to do, I want the result to be showing in one of the numbers. So I'm going to use an indicator that is going to indicate the result. Okay, so remember, see how I chose an indicator and not a control, because I don't want to be controlling the output. I want it as a result. So this has to be an indicator, okay, because it's going to indicate the result. And then the wiring connection comes in here. First, I'm going to attach it to the wall. Okay, so these inputs are available to me for each of these cases. Okay, I may or may not use them, but at least they're available for each of these cases, right? And then for this, okay, yeah. In case 0, I am adding the two inputs, and I am making sure the output is available to me here. Okay, for case 1, I want these two inputs to be multiplied. Okay, right. For case 2, I wanted these two to subtract, and I'm just going to make these wiring connections. And for case 3, maybe I just want to take a square. Okay, and it's a square, so whatever number is in numeric 2, it's just going to get squared and then get displayed right here. Okay, so so that's how I could go ahead and implement my my system. So let's have some numbers. For example, let's have 10 here, and let's have 5 here. Okay, so 10 plus 5 is 15, right? Why is it adding them? It's because my numeric, let's just call it, for simplicity, let's just call it case selector. Okay, so I'm just going to call it case selector. Okay, so right now my case selector is 0, and you can verify for 0 our implemented logic is addition. Okay, so if I choose my case selector as 1, which 1 corresponds to multiplication, right? So it's 10 times 5 is 50. Case selector 2 was subtraction, so it's 10 minus 5 is 5. And case selector third case was the square of numeric 2, so 10 squares is 100. So that's just another example of implementing different things for different cases, and this time we had different cases as 1, 2, 3, 4, and you can have many of them, but remember to always set one of them as default. Right, so if we choose a case, for example case 7, which we don't have in our system, what is that going to do? So case 7 is subtracting them because we did not have case 7, so it ran at the default case, so that takes care of it. So this was another example to set up different cases, and those could be more than the true and false cases, the Boolean cases. You could have multiple cases. Right, so what I would want you to do is implement some things. For example, go into comparison and look into certain comparisons here. So for example, I would maybe want you to compare this number in this example. So if we had any number here, and the result of case 1 was multiplication, so when the two numbers get multiplied, see if this is greater than something. Okay, let me wire this up. Yeah, so compare this with a number. You could choose a constant, you could choose any constant here. Let's have a numeric constant. Let's wire this up. Right, yes, it did get wired. Okay, so you can maybe compare it with 50. If this number is greater than 50, then maybe you could light up an LED. Okay, so I'm going to place an LED here and then make a connection with this LED. Right, so what this is doing is it's just comparing that if this multiplication result is greater than 50, the LED should light up. If not, then it shouldn't be lighting up. Okay, so in this case the LED does not have any value, so what we are going to do is assign some value. This is what the error would be as well, by the way. As you can see, missing assignment to tunnel, so 3 times we have got this error, and that is because we should have assigned for other cases. So we assigned a value to the LED, but we did not assign a value in case 2, 3 and 0. Okay, so we can always give them a value here, and a nice way to do it is to go into Boolean and assign a false constant that we probably just want the LED to remain off for the rest of the cases, because we are not interested in the other cases. Right, so LED is going to remain off, but only in this instant. If our answer is greater than 50, it's going to turn on, otherwise it'll remain off. So that's another example. Let's see if our result is greater than 50. Right now it's again, we have to choose the first case, and our result is 50. The LED is not turned off, so if we increase it to 50, 55, then the LED gets turned on. So that's one of the ways you could include other operations in your system by making use of numbers and LEDs. And similarly, you have many options that you can look into. For example, you might want to look into horizontal or vertical, these bars to represent some numbers. Maybe you have a thermometer as well, you have a tank, so you could always use these interesting representations for your examples, and I would encourage you to practice these and go ahead and try and implement a system of your own. Obviously, if you have any questions, any difficulties, we can address them in the comments, or you can just send me an email. Thank you.